Hello and welcome back to a new video in my C++ library series. In this series, we're gonna take a look at a new C++ library every week. In today's week, we're gonna take a look at PugiXML, a lightweight, simple and fast XML parser for C++ with XPath support. So in general, XML, it is a certain file format. We're gonna go into the details in a second. And what PugiXML does, it is basically reading this file format. Now it is kind of like similar to Enloma.json. Enloma.json kind of like reads, writes, and modifies JSON data, and PugiXML reads, writes, and modifies XML data. Now PugiXML, similar to Enloma.json, is available as a nice license. We have a mid license here. It is quite lightweight. It's just 3 files, one CPP file, 2 header files, and there's even an option to get this as a single header file. So really easy to integrate into your projects. It is very good documented. There are 2 examples that already show you how this is working. They have an extensive reference manual, and they have a good quick start guide so that you can get started, right? This is quite extensive. There's everything in here, including changelogs and API references. There's a quick start tutorial, which is getting some text around the code and is actually quite long for a quick start tutorial and really goes into many details. And if you are basically following this quick start, you basically know how to use PugiXML. Right, and we're not going to go to the quick start. I have my own way of doing it, but basically what I could do is just reference you to the quick start guide and say, hey, let's read this and see how it's going on. However, you are here to basically see how I'm doing that, maybe to just put me as a podcast on your ear while you're commuting back to home from work, how I tend to do it with other programming videos that I watch, and basically just getting a bit of information about the libraries. Now, PugiXML can be downloaded here. They have releases available. They are not updating the releases too often. I think you can also take the code from the source directory directly, since they are using CI/CD. Not sure what they really use in the background, but probably no CD. I don't know if they are using deployment for packages to Conan. I don't think so, but at least they are using continuous integration to validate that all of the builds are working. Now, there's also the option to gain access to PugiXML via Conan. This is how we're going to do it. They have a Conan recipe available in the Conan Center. It is highly configurable. You have the options to turn on or off a shared library. You have the option to get this as a header-only library. You have the option to turn on the support for white characters, and you have the option to disable exceptions. By default, they are configured as follows: no shared library, no header, only no wchar with exceptions, and this is kind of like most of the time the thing that you want to go for. Now, we want to, of course, learn how PugiXML works, so we're gonna need to get started. I've already prepared a template here. This is my MoxPP template. MoxPP is my template for Conan plus Premiake 5 builds, and basically it comes in the way as it comes here. Of course, not in the PugiXML subdirectory. Basically, all files here from app to readme, and you can customize this very easily. You're gonna see how fast it works. First of all, you open up your Conan file and enter your dependencies. By default, there's some SPD log in here. We don't need that. We put in PugiXML. Now, after that, I need to do a bit of configurations, or I should do it in mox.lua. I'm going to change the name here to PugiXML, since I want to try out and play with PugiXML. Now, in source, there's a build.lua file, and there is configured how the project is laid out. Now, normally I could say and also say PugiXML in here. However, I'm going to underscore this with example, because it's then going to have name clashes if I'm not going to put this as an underscore, since the library and my project would be named PugiXML, and Premiake would not be able to link this correctly. So I'm calling this PugiXML underscore example. Now, of course, you don't need to have my MoxPP template. You can, of course, also download it on your own, create your own static library, and do everything on your own, and it would be fine as well. Now, what I go is I'm going to go into that folder here with the console, and I'm going to run mox init, which is basically initializing the Visual Studio project. If you want to do this manually, of course, you can do it. You can create manually a Visual Studio project and manually copy these 3 files over. Would be as simple as that, but I honestly, to say, just want to promote my template with every library again and again. So you're going to see every time how nice my template is, and that you at some point maybe want to use it. All right, so there we go. We are now inside of Visual Studio and everything is configured by my template automatically. And we have a nicely and friendly main CPP already available. Now, of course, the main CPP tries to run this with SPDlog, but SPDlog is not in here. I want to, of course, test PugiXML. Now, for testing PugiXML, I am going to include PugiXML. It's PugiXML.hpp. We're probably going to need it. IO stream is what I'm also going to include so that we have some SDDC out. All right, so now inside of our main function, we can get started and write our code with PugiXML. However, before we can do that, we first need to actually know what an XML file is. Now, I'm not gonna show you any other files. I'm just gonna plainly write an XML file. I'm gonna assume if you're a software developer, you know how XML works, but I'm also gonna revisit how XML works so that for the people that have not seen an XML file, that they can also at least see the basics on how XML works. All right, so example.xml. I'm putting this into the app directory since this is my working directory configured by my template. I have a shared working directory for every project. This is also indicated by that file here that I'm going to delete, and now we have our example.xml. Now, how is an XML file built up? Well, basically an XML file is built up in a hierarchical way and is built out of nodes and attributes. Or yeah, we could say that these are all nodes, but most of the time it's like nodes and attributes. Now, an XML node is always indicated by these pointy brackets. This is basically an XML node. Now, this XML node is of course not really useful since it's not browsable. We need to provide a name for that node. So this is my root node, so I could call this root or project. I'm just going to call this node here project so that we can see how this works. So now I have an XML node project, and by creating that node, I'm basically going to say, all right, now the project section is going to begin. So everything else is going to go into that level of indentation because now I'm inside of project. Now, if I want to end the project, I'm basically going to write project again, but this time I'm going to prepend a slash here. If I prepend a forward slash here, then I'm basically going to say this is the end of the project, and you can already see Visual Studio Code is recognizing that, and it allows me to collapse this project node here. All right, so now I can write something inside of the project node. Now, I could, of course, write a plain text in here. This works on XML. I could say this is my project. This works because XML supports that. For example, if you're wondering who is also using XML, HTML. HTML is basically XML, and it's kind of like converted to HTML by the browser. The only difference between XML and HTML is that the HTML is basically interpreted and rendered by the browser, while XML is kind of like just used as a generic way of displaying stuff. Of course, they have adapted a few things for HTML, so it's not one-to-one in the same relation, but in general, if you know how to write HTML code, you also know how to write XML code. Now, instead of the string, I can also provide other types. For example, I could provide a tag called name and this tag here, and I could provide the name of the project. So my project, I can provide it like that. Then I maybe want to have a description. So I'm going to open up a description tag that I'm going to end here and call this one, this is my personal project. And what could be in a project? Well, in a project, there could be, for example, items. Items would be something that would be quite useful to have in a project so that we have multiple items contained in there. And then I would have a single item. Now, of course, what we can do in XML is now you can describe an item similar to how I describe my project. So I could have an item name. This is my item. And then I could have a item type, for example, call this one maybe like string, and then of course also end this with type, and describe the item like that. However, I also told you that XML is built up out of attributes, and that's something that I want to use here. I want to now use attributes to specify my item details instead of the content in the actual XML tag. Now, what you can do is to provide attributes is basically add something to that tag. Now, the tag is always just the first name, and everything that follows is basically an attribute. So what I can do is I can provide an attribute called name, then I can write like a equal sign and then some quotation marks, and then I have basically a container and describe the name. So item 1, for example. And then if I want to do this for the type as well, sorry, without a Kommata, this is JSON, comma, and this is XML. And I can provide like a string, and maybe I want to also provide a value, or I could provide also the value in here. So yeah, my string for ETM1, for example, item 1. Then what I could also do is I could provide another item, call this one like file 1, and have this one like a file, and then provide like the path to it. And this should not be there. Like C users, I think tutorial, documents, my strings.txt or something like that. So you could like write a XML file like that. Or what you could also do, if you would have like a null item which has no path associated, or for example no path is currently provided, I have like my file 2, which is also a file, but there's no file provided, and then I would basically close my item tag like that, /item, and close my item tag. But what I could do as well is I could also make a shortcut version of that and basically close my tag like that. This is also possible. This is the shorthand to directly close an XML node or tag, however you want to call it, an XML node directly in the same line. So if I have no value, I can directly close a node like that, and then I have kind of like, yeah, in this case, like a null value. Alright, so this is basically the idea how XML works. Of course, there are more things available. There are, for example, also comments, just that you know how they are. Comments are really useful. This would be, for example, an XML comment. This will not be parsed. I mean, it will still be parsed. PugiXML has support for comments. PugiXML will also keep your comments, different than in LomanJSON. In LomanJSON stripped your comments away if you would have some JSON C style, so JSON with comments, but in LomanJSON would not allow these, but PugiXML actually has support for comments and is actually even storing these comments. And you can even add comments and modify them in the application, but just that you know, right? There are also different XML tags like special property XML tags, CData tags, and more advanced stuff like that, but I don't want to go into too much detail on how XML works, since this is all about the library. Now, speaking of the library, we want to now use PugiXML. Now, how can we use PugiXML? Well, in PugiXML, everything is in the Pugi namespace. And yeah, this is the Pugi namespace. And inside of Pugi namespace, you have many, many things that you can use. For example, the so-called XML document. XML document is kind of like a XML file. It doesn't need to be a file, it's just a document. It doesn't need to be backed by a file on disk. You can also have like a virtual document that just lives inside of C++, but in general, document is the container where you can serialize into, or deserialize into and serialize out of. So document is kind of like a serialization container about the then following XML nodes. Now, how can you put in data in a document? Well, you can put in data by calling the load function. By calling the load function, you're basically going to put data in here. Now, you can load from string, as simple as that. Maybe even W string. No, because we didn't compile with W string support. Now, you can basically load inside of a string. You can also load into a buffer, so kind of like a void pointer and a size that is defining how big the buffer is. It's also possible. And the nice thing on PugiXML, it also has a load file method, so you can actually directly load from a file without creating a stream. Of course, it supports the stream. I think the normal load has support for a in-stream, yeah, even for wide in-stream and the normal in-stream. So you have the option to kind of like open up the file as a stream and then load this via the load function here in general. However, we are fine with just loading this from file, example.xml, and this load function is actually returning us something. It's returning us an, I think, a XML parse result. Path result, yeah, XML path result is what we're going to get from it, and the XML path result will contain what happened. So I would probably want to check this. Now, the path result has multiple members. It has a function to get a description. The description is basically going to tell you if something went wrong, what went wrong. You have an encoding stored in here and an offset. The offset is basically for how many characters the file could have been passed and when the issue occurred. Here, so kind of like have a bit of information on where the problem occurred, and you could use that one to kind of like find out which line and stuff like that, and do some advanced error information on why it failed. Encoding is just a file encoding, and then you also have a status in here. The status is actually the kind of like binary format of the description. It is containing multiple values for different issues that can occur while parsing. Or what we can also do is we can use the operator bool, which will result into true if the document was read successfully. So what you can do is just do something like if res, or do something if not result, and do maybe something like stdc out result dot description if something went wrong, and then maybe like a return -1 in here to kind of like indicate that something has gone wrong. And yeah, that's kind of like the idea. Now I can like start the application, see what I get. I shouldn't get any output because my XML file should be valid. Yeah, I don't get any output. This is good. However, what I can do is I can try to make an XML invalid, which is, to be fair, kind of hard. Maybe pp project ddxx or something like that might fail it. I'm not quite sure, but this could result into the XML not loading correctly. So let's see if this is the case. Yeah, error parsing start element tag. So we basically get an information that it failed to pass the start element tag, and the start element tag is basically yeah, the tag that started this element here, and this tag failed to parse because it had basically probably the issue is that we have 2 times a opening bracket here, and this is then failing. All right, so let's make it valid again so that we are good. And there we go, XML loaded. Now, what we need to do is we need to, of course, work with the document. So how do we work with the document? Well, we work basically with the document by querying the values. So in this case, I want to get something from my document. I can get this by calling the child method. The child method takes a string, which is basically the name of the child that we want to get from it. And since the document is kind of like the main root, the child in this case is the project. So I can do like child is project. And I want to even like go further and get the child from the project itself. So I can do the child method again, because basically the document is an XML node, and the child here that's returned is an XML node. And so I can kind of like query my way down until I find like my name. And now I have the name, and I could try and maybe get the value with the function value and try out if that works. So stdc out, document, child project, child name, dot value, and then we can see if we get something, and we do not get something. Well, this actually is a certain edge case why we are not getting anything. The edge case is that actually this is an XML node, this is an XML node, and this is an XML node. So while this looks like a string, it actually isn't. It is actually not a string, it is actually a child node of the name. So actually this is kind of like the first child node that you can access by calling the first child, and then getting the value from there. So this one should work because it's kind of like a nested element node in there. And now you can see I get my project. Why is this the case? Well, basically because an XML tag is most of the time containing another XML tag. And in this case, it shall contain a string. However, this doesn't work because like this XML tag, it is basically need a way to indicate that this is a pure string, so they actually nested a tag in between. However, since this is kind of like bad to see, there's actually a function called text where you can retrieve this as an XML text, and an XML text can be represented in multiple ways. Since everything in XML is a text, even if I would try to indicate an integer, if I want to try to indicate an integer, I still need to put this into quotation marks. So in XML, everything is a text, and then I can kind of like parse this as a certain value. In this case, I want to parse it as a string, but I could also parse it as a as something else. And if I do it like that, it also works. Now, this is kind of like the preferred way, which is basically kind of like getting the first child and converting it into an XML text. So this is kind of like the proper way of accessing this certain edge case. Now, of course, the certain edge case is not very interesting. We want to take a look at our items that we have. So basically, I want to pass all items and get the name and the type from it. Oh, yeah, that's what I want to do. So what I basically want to do is, instead of taking a look at the name, I want to take a look at the items, and now I want to iterate over them. So instead of directly couting them, I'm actually going to store them somewhere. What is the type of that? So let's call this one items. What is the type of the items? Well, the type of the item is a PugiXML node, so let's write this out. Everything is a PugiXML node, and that's quite kind of easy. Now, of course, what I want to do is I want to iterate over my items. Now, how can I do this? Well, there are multiple ways of doing it. I can get the first child, and if I have the first child, so let's call this one C, I have the first child, I can always ask to get its next sibling. Now, why do I get the next sibling? Because if I am on the items node and I'm going to get the first child, I'm going to get item. And to get the next item, I do not need to go deeper into the children itself. I need to go to the kind of like sibling of it. So we're basically with first child, we are going the hierarchy level deeper, and then we kind of like need to stay at the same hierarchy level by getting the next sibling. And this is always an XML node, and an XML node is actually just a pointer. It is a lightweight handle for manipulating nodes in DOM tree. So DOM is document object model, and it is a handle, and the handle is a pointer. So if you want to check that this one doesn't never work, you basically do it like that. So while C is valid, you're basically going to go in here. You can compare this with null pointer, while it's not null pointer, or while it's not PugiXML null is also available. PugiXML null is basically null pointer, because the XML node, if we will peek in there, is basically just containing one member, which is the XML node structure, which is the internal stuff. It has, of course, a few functions assigned to it, but basically the only data that it has is it has the handle, the pointer to the actual storage. Now, basically, you can do it like that. Of course, it needs to be C equals C next sibling, and if you know that, if you know me, you know that I can kind of like enroll this into a for loop. So the for loop would look something like... Now, of course, I need the whole statement, something like that. This would be kind of like the for loop. But since we are on C++, we do have range-based for loops, and PugiXML supports them. So for PugiXML node item in items does actually work. You can do it like that, and it's basically then going to iterate over all the childrens. You can do this explicitly by taking a look at the children, because there could be also attributes, and then you could also iterate over all the attributes, but attributes are actually something different, but we're going to get to that in a second. Now, there you go. You kind of like get all the items enumerated, and now the only thing that I need to do is I want to basically iterate or basically print out what's inside of the item. I can basically start with my item value, because we already know them. We can parse this to text, and then as a string, if we are doing it like that, you're gonna basically get the value that's assigned behind there. This should work. Now maybe let's add a std out so that you can already see how it works, and not cout and endl, of course. And there we go. Now we can iterate over the items, and you can see that we are getting the my string for item 1, we are getting the path, and we are basically getting an empty string. So the text method is actually safe for not having a value. First child is not, because first child can return like null pointer, and if I would do the value game here, this is expected to crash, which it doesn't. Interesting. Maybe, yeah, probably because I directly access the value method, which is, get node value or empty if node is empty or has no value. So it is kind of like already catching that. However, this is, since it's basically a null pointer handle, and PugiXML is catching this behind the scenes, so it's giving us a default value there as well. Still, I recommend using the text method, even though this is kind of working. You could also try out printing the whole node, which might be interesting. What happens? No, okay, it's just printing the pointer, so this doesn't work. So that's basically what I want to do. I want to get the text, and I want to get this as a string, right? This is basically what I want to do, but that's not everything that I want to do. This is just the value that I want to see out, and maybe I should concatenate this then down in here to kind of like have the value here, like an equal sign, and then I have the value. And what I also want to do is I want to get the attributes of it. So the attributes, where these fields, name and string. Now, getting the attributes can be done in the straightforward way and in a bit more complicated way. So what I could do, for example, is I could just say item and then call the attribute function, provide an attribute name like type, and then provide the value here, maybe like with a space, something like that. And then I should like get the type of the item. So string is my string, and then we have two files. One of them is empty. So this actually works like a char. However, this is not how I want to do it. I want to do it with the proper way because we have for and we can go over them. So for Pugi, and now it's a so-called XML attribute. Attribute in item, and then maybe I can just directly do it like that. No, I can't. So in this case, I need to manually call the attributes function. Above here with the children, it seems to work, but you could also do this explicitly by calling children to kind of like gain access to them. And now down in here, I want to now actually see out the attributes. So attribute.name kind of like gives me the name of the attribute, and then I can like a double point, and then I can give it the attribute.value, which is directly a string. You can also do it like that and get it as a string, and you can also convert this to like booleans. Now, conversion of them, maybe we're going to take a look at them later on. Then I want to add like that one in here, and instead of having them there, so something like that. And if I would do it like that, I would expect all attributes to be enumerated. So yeah, name is item 1, type is string, equals my string for item 1, and so on. Now, if I would really want to like parse something to an integer, so I could have something like id equals like 5, or maybe let's enumerate them into something that makes sense, like 1, 2, I can't count, but something like that. If you would do something like that, if you want to do it, then you can also convert this. For example, I can do something like int id, and id would be like attribute or like item attribute id, and then like as integer. You can also do this as an uint, but I'm just going to do it as an integer, which is going to try to convert this. You can provide a default value. So I could say something like -1 if the ID was not found, and then I have some catches in here. So the only thing that's then like required is also printing the ID. So cout, and then like the ID, and then the bracket, and then we're gonna get all the values. And if I run it like that, you can see that we have like 1, 2, 3 nicely numbered. Now maybe let's make this a bit more funnier. 3, nothing, and 1. If we would do it like that now, let's see, you can see that we now have 3 minus 1 1 because the ID was not valid, so we got -1 there. And we can also like provide a wrong value. So if I would say like ID like lele, something like that, and run it then as well, we also should get actually now we are getting 0. That's interesting. Okay, that's interesting. It should actually give me -1. I don't know why it gave me 0. That seems to be some bug in PugiXML. Maybe this is something that was probably already fixed, but I haven't take the Conan version, not the latest one on the branch. But normally this should not give me something valid. But yeah, for now this should be fine, right? So everything is good. Now, what I also want to show you is the so-called XPath extension to PugiXML. Now, basically, XPath extension allows you to kind of like index and query XML files. Now, XPath itself is kind of like a bit more complicated and a bit more resource hungry, because it requires to kind of like iterate over the whole document, find out the right nodes, and needs to be parsed and stuff like that. But what you can do is you can run like doc select nodes and then kind of like run a query. In this case here, for that example, profile tools tool is kind of like the base path that we want to access. So instead of profiles, instead of tools, we want to get a tool, and then we provided kind of like a query string which said that I want to have an attribute called timeout that's bigger than 0, and this kind of like allows you to query the XML file here. We can also do it inside of our code, of course. So what I can say is I can say document was not query, it was search. Was it search? No, select. Select node or select nodes. In this case, it's going to be nodes, plural, because we're going to have a bit of a longer query. So PugiXPath node set. Nodes equal select nodes. And in our case, I want to find project items item. And I want to have a type of file. This is basically what I want to now find. I want to find my project's items, an item with a type that is file. And then what I can do is I think it's then going to be an XML node, maybe, or maybe not. Let's see. XML node, item, nodes, in nodes. And I can basically iterate over them. No, I can't. So then it's going to be an XPath node. There we go, it's an XPath node, but the XPath node, Iteme, no, just item, and item. And then basically what I can do is I can get access to the XML node by calling the .node function. And what I then can do is I can basically copy and paste that code, but I don't want to do it. I just want to have the value. So I'm basically just going to say text and or as string. To get this as a string, so let's stdc out and say that we got an X here because of XPath, and then I want to have kind of like the string name. And if I run it, you're gonna see that we're gonna get multiple X's here. Of course, I forgot the end line. And maybe to make the output a bit more nicer, I should also assign a value to that. So lel is the string path of this one. And if I do it like that, you're going to see that we're going to get the two nodes that were matching here. So that path and the other path. So basically, what you can do is you could remove all of that code above here, or not just all of that code, because that code was basically just carrying and iterating all of them, and you can just replace it by one of these XPath query strings. Now, these XPath query strings are very, very powerful. I don't want to go into too much detail of that, because this shouldn't be an XPath or an XML tutorial. It should be a tutorial about PugiXML and how to use it. Now, of course, until now, we just use PugiXML to get the data. Now, what I actually want to do is I want to modify it. So instead of writing this out now here, I actually want to now obfuscate all of my paths by basically encrypting them to a empty string. This is a nice encryption because nobody can actually read them afterwards. Pun intended, no, you can't decrypt it anymore. It's not an encryption, but it's just fun. Yeah. So what I can do is I can go inside of that node and I can now actually work with it. So what I previously done is I have kind of like added text. In this case now I want to modify the text. So actually what I'm going to do is I'm going to get my first child, because this is where the text is encoded. Text is kind of like just a I can actually assign that text to something differently. Yeah, I can. So let's do it like that. So I want to set the text to lol, you got trolled, because I basically corrupted your XML file, and I just want to basically screw you up and troll you, so you run my application, your XML file gets rid of all paths. And that's kind of like the idea. All paths are corrupted now. Of course, you shouldn't do that, right? And then what I want to do is, of course, now save this. Saving it is also very easy. Document, save file, and then I provide the path ./example edited.xml. And I'm just going to plainly save this down to disk again. And if I run that now, boom, application finished. Go to Visual Studio Code. We have our example edited.xml, and you find now the lol you got troll text in here. Of course, something that also happens, it is appending an XML version. This is something that's always in an XML file. You have kind of like this question mark XML version. This is a special XML tag. We didn't have this in here, and PugiXML basically just appended that, so that is a bit more accessible. Also, like encoding is something that you sometimes also find here. These are all stuff that PugiXML adds automatically, which is nice because it's basically, it's kind of like the norm to have it in there. Now, what we can do as well is, of course, also add something to that. So if I would again select a node, before saving it maybe. So if I do like doc select node project, yeah, let's just go to like project. Let's select the projects node. Now this is a bit yeah, unresponsible to just get one node by calling the select node, but I kind of like XPath. XPath is nice. Let's call this one new n or nn for new node, something like that. And or no, it's not a new node. This is actually just nd for node. And what I can do is I can append a child. Appending a child basically means adding a new child on there. I can call this one new node. And now that I have the child, I can call this one like nn, which is my new node. And let's add an attribute to that. So append attribute. Attribute here, and then I have also the attribute here. I don't need this. I can just want to set the value here to maybe something like -55 to basically just add an attribute in here, and then maybe let's add some text to the new node as well. So new node text is gleich. This is this is new. Just this is new. Unexpected would be too long to write for me. And if I run that code, we should now have a whole new node crafted. So now we have the new node in here. Attribute equals -55. This is new. So you can see that PugiXML is really a nice library. You can mix and match all these XPath madness, create new nodes very easily, and everything is kind of like nice and fine. It's a document, and this document is your container. You don't need to worry about these handles. These handles are just pointers. You don't need to make sure that you always have a reference and stuff like that. No, they are all auto-managing. You have nice functions like append an attribute, append child, finding these. If they were not found, the most methods are going to catch it and give in an empty value, or you could provide a default value, even though it didn't work here for some reason. And yeah, you have like so many options to work with PugiXML, and I really love it. To be sure, like PugiXML is one of my favorite libraries, JSON libraries. Like with Enloma JSON, I now finally came to the conclusion that I want to always use Enloma JSON, but it was not a decision that was as easy as PugiXML. PugiXML is basically the first and last XML library that I've ever used. Maybe you should never say never, but PugiXML, saw it, used it the first time, fall in love with it. JSON libraries, different story. I started with Enloma JSON and then also used a few different libraries, but came back to Enloma JSON. But like PugiXML for PugiJSON would be something that I would definitely use. Let's say it like that. Even through that Enloma JSON is like nearly doing the same, but it's header only, and that's sometimes not a good thing. Okay, so yeah, thank you for watching. I hope you enjoyed. Next week we're gonna have a new library. Shall I already spoiler you what we do? Yeah, let's spoiler you. In the next week, we're gonna talk about FMT, the formatting library. So yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.